Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aya Shafiqah binti Abdul Rahim from Bachelor in Science, Biology, UITM Perlis, and my supervisor is Sir Muhammad Azhar bin Zulkifli. Welcome to my presentation, to my panels and all viewers. Today I want to present my viva with the title Potential Antioxidant Capability of Extract from Brassica oleracea var capitata F. rubra as Natural SPF. In the introduction, the electromagnetic radiation of ultraviolet is split into ultraviolet A, ultraviolet B, and ultraviolet C. Ultraviolet radiation overexposure can cause sunburn, wrinkles, lower immunity from infection, premature aging, and cancer. The UVA ray penetrates the deeper dermis and produces reactive oxygen ROS molecule, which can cause mutation in DNA, which result in loss of enzymes that involve in the biological process and energy metabolism deficits. The erythema of sunburn and suntan in the skin is primarily responsible for UVB. Sunscreen used to encourage normal body defense mechanism to defend against the dangerous UV radiation from sunlight. The first problem statement is the chemical sunscreen contains oxybenzone and otenosine will cause hormonal disturbance in both humans and wildlife, corroborating and also orogeny. Second, individuals with allergic skin hypersensitivity are not interested in chemical sunscreen because of concern about the skin exposure to unfamiliar chemicals. And lastly is the limited reports on the correlation between sun protective factor values and the antioxidant capability of the red cabbage. The first objective in this study is to extract dry red cabbage by using inorganic solvent in maceration extraction. Second, to determine the antioxidant properties of the extract using DPPH assay and total phenolic content. Third, to analyze the bioactive compound using HPLC chromatography. And fourth, to examine the correlation between sun protecting factor and antioxidant capability of red cabbage. In the role of UV radiation, UVB radiation induces the cycloputene pyrimidine dimer CPD and the pyrimidine 6,4-pyrimidone photoproducts C4-PPS in cellular DNA lesion, which shown to be mutagenic and cause the development of tumors by causing cytosine to thymine and or cytosine to thymine substitution. CPDs are more common and more mutagenic than 6,4-PPS. CPDs induce cell killing and play an important role in photocarcinogenesis by induction of mutagenicity and immunosuppressive effects. Sunscreen are used to help the body's natural protection mechanism to defend against harmful. Its function is based on its ability to absorb, reflect, or separate the sun's rays. The sun protection factor SPF is measured by comparing the amount of time required to produce sunburn on sunscreen protected skin to the amount of the time needed to cause the sunburn on unprotected skin. UV radiation can be absorbed effectively by sunscreen containing chemical filters, high absorption, as well as broad spectrum coverage in the UV field to avoid harmful skin penetration. However, long-life excited states can themselves be hazardous to the skin due to the reactive oxygen generation or increased reactivity. Several studies have reported that the use of oxybenzone and benzophenone and autocrylene, which are widely used in the production of chemical sunscreen, have shown toxic effects like dermatitis and photoallergy. The natural antioxidants from plants are widely used in traditional medicine, including flavonoids, phenolic acid, tocopherols, monotropins, and nitrogen compounds, which are alkaloids, amines, amino acids, and indoles. These compounds can help prevent UV radiation from penetrating the skin, which reduces inflammation, oxidative stress, and DNA damage. Red cabbage is one of the high nutritional value as it is rich in antioxidants, minerals, vitamin, oligosaccharides, and several bioactive substances such as anthocyanins, flavonoids, and glucosinolates that have a positive impact on human. Vitamin C contributes to the production of dermis, skin barrier, and collagen, and functions physiologically in the skin against oxidation, wrinkle anti-aging, and the cell signal pathway of cell growth and differential development, associated with the occurrence and development of various skin conditions. Antioxidant vitamin A alpha tocopherol can help protect the animal and plant cell membrane from light damage and has shown a reduction in acute and chronic skin photodamage through the topical application of this antioxidant. Studies have shown that vitamin A able to degrade malignant melanoma and T-cell lymphoma epidermal transfer, reduce oil secretion of common acne and the number of bacteria in the epidermis and capillaries, and inhibit the immune response of monocyte and neutrophil. Flavonoids are the secondary phenolic class of plants with essential antioxidant and chelating characteristics. The protective effects of flavonoid in biological system are due to their ability to pass free radical electrons, chelate metal catalyst, trigger antioxidant enzyme, suppress alpha tocopherol radicals, and inhibit oxidase. In addition, flavonoids protect plants from ROS-generated solar UV radiation and scavenge. Quercetin has been shown to protect the skin antioxidant system and UVA radiation harm in rats. Total amount of anthocyanin in red cabbage was 2.32 mg of cyanidin. From the chromatographic graph shows the peak 1, which is cyanidin 3-diglucoside. 5-glucoside is dominant anthocyanin in red cabbage. High anthocyanin concentration were also estimated in cyanidin 3-sinopoi, diglucoside, 5-glucoside are present in peak age. The total content of carotenoids in red cabbage is 0.35 microgram. From the figure, dominant carotenoid found in red cabbage were all trans-beta-carotene, which is shows in peak 18, and all trans-lutein, which shows in peak 8. Carotenoids contains in red cabbage are beta-carotene, beta-cryptoxanthin, lutein, violaxanthin, and neoxanthin. The most abundant glucosinolates in red cabbage were glucoraphanin, sinagrelin, and glucobarisine. However, 4-hydroxyglucobarisine, 4-methoxyglucobarisine, and new-glucobarisine were also found in trace amount. From the picture shown, glucopharonin in peak 1 was predominantly decommitted, followed by sinagrelin among the aliphatic glucosinolate from the red cabbage. Glucobarisine, which is peak 8, is measured among indolate, and glucosalpine, which in peak 4 is the main aromatic. Preparation of 80% methanolic extract. First, red cabbage need to be dry for 5 days. Then, dry red cabbage were powdered. After that, 3.5 grams of red cabbage powder was extracted with 400 ml of methanol with 80% at room temperature for 48 hours. Then filter the extract. After that, dry in oven at 37 degrees Celsius and keep sample at 4 degrees Celsius. In DPPH radical scavenging activity, first prepare different dilute concentration of extract. Then prepare 80 microgram ml DPPH solution. Then add 2 ml of DPPH solution into 2 ml concentration of extract. The stem for 30 minutes in dark at room temperature. Ultraviolet absorbance of this solution had been recorded and a spectrometer at 570 nanometer using Trolloc without DPPH as control. Then calculate the percentage inhibition of free radical and IC50 by using graph paper. In total phenolic content, first prepare different dilute concentration of extract, prepare Folin-Chakotay reagent, and add 1 ml of Folin-Chakotay reagent and 2 ml of NO2CO3 into the dilute concentration of extract, and the mixture was stood for 2 hours with intermittent shaking. Then absorbance had been measured at 760 nanometer. After that, the same procedure was repeated for standard gallic acid with the different dilute concentration. In chromatography analysis HPLC, 5 microliter of sample solution had been injected into a HPLC system with a flow rate of 0.2 ml per minute. All chromatographer measurements were made at 45 degrees Celsius. Bioactive compounds were identified based on the comparison of their radiation time and UV visible spectrum. In vitro evaluation of some protective factor, first prepare 2 ml with different concentration of red cabbage, then observe the absorbance value by using spectrophotometry in range of 290 until 320 nanometer, then calculate the SPF value using Benson. I will continue with the result and discussion for the part of DPPH radical scavenging activity. DPPH assay is based on an antioxidant's ability to donate hydrogen radical or an electron to the DPPH radical, which is a stable free radical with a deep violet color. When an odd electron is paired in the presence of free radical scavenger or antioxidant agent, the DPPH radicals are reduced to the corresponding hydrazine. DPPH H form and the solution is decolored from deep violet to light yellow as shown in the picture. DPPH assay are turned to yellow after mixed with sample extraction and stand for 30 minutes in dark. Based on the result, the percentage of free radical scavenging activity increased when the concentration increased. The highest concentration of red cabbage extract is 500 microgram microliter. So the highest percentage of inhibition calculated in this concentration is 56.03%. The highest percentage inhibition of Trolloc is 87.39%, and it was calculated at the highest concentration of Trolloc. Trolloc is usually used as a reference compound in DPPH assays due to its good in free radical scavenging and good in single electron transfer and hydrogen transfer. Hence, many free radicals can be scavenged efficiently by Trolloc. The percentage inhibition of various concentration was used to calculate the IC50 values. The total phenolic compound in methanolic extract were calculated using gallic acid as standard by the Folin-Chakotay method. The Folin-Chakotay method is based on the transfer of electrons to blue color complex in alkaline medium from phenolic compounds to phosphohomolymeric phosphotungstic acid complex, which are spectrometrically determined at 760 nanometer. As you can see at the picture, the blue color are changed after 2 hours. A standard curve and the best fit lines were plotted based on 3 repetition average of gallic acid absorbency, yielding the following equation with a 98.3% correlation coefficient. The content of phenolic compounds in red cabbage was calculated is 36.37 mg GAE over 100 gram by using the equation y equal to 0.029x plus 0.1874 and the average of triplets result. The relationship between antioxidant activity and total phenolic content is shown that the study plants and herbs that phenolic compounds are the main antioxidant compounds. Phenolic compounds can act as antioxidant due to their redox properties. Because the hydroxy groups act in free radical scavenging, the total phenolic concentration could be used as a basis for rapid screening of antioxidant activity. In general, the sunscreen products are categorized based on the SPF values, whereby the value from 2 until 12 are classified as minimal protection, 12 until 30 are moderate sun protection, and the SPF value of sunscreen product above 30 are classified as high sun protection. A sunscreen product should have a wide absorption range between 290 to 400 nanometer to be more effective in preventing photoaging, skin wrinkles, sunburn, and other skin damage. The result in the table shows this absorbance value of the methanolic extraction of red cabbage in the range between 290 nanometer to 320 nanometer. The total SPF in methanolic extract red cabbage is 2.336. The correlation between SPF and antioxidant was significant, which R equal to 0.902, P equal to 0.003. It was confirmed that the antioxidant has the capability of SPF. From the result, it was observed that the test methanolic extract of red cabbage possesses low value of SPF. However, they still have a lot of skin benefit as antioxidant protect against oxidative stress and combat the free radicals that tend to come up with long exposure to the sun. The combination of the antioxidant from red cabbage with the organic chemical filter will give a great combination. The study from Souza showed that the sunscreens containing antioxidant and organic UV filter, which are spirulina and dimethyl Cromanol have a great protective effect in the UV region, eliminating the UV-induced reactive oxygen generation in the
conclusion. Methanolic extraction of red cabbage with 80% of methanol by using maceration extraction show a great amount of bioactive compounds. Red cabbage contains high antioxidant and tocophenolic contents. Anthocyanin compounds in red cabbage are curcuminic acid, ferulic acid, and caffeic acid. Glucosinolates compounds in red cabbage are glucoraphanin, sinigrin, and glucobarazine. The most carotenoids in red cabbage are beta-carotene, lutein, lycopene, and zeaxanthin. They have shown the correlation between antioxidant and SPF. The recommendation for this study is the technique of extraction need use a technique that can reduce the extraction time and can improve enhance recoveries of analytes and reproducibility. There are several modern methods that can be used for extraction such as microwave-assisted extraction, ultrasound-assisted extraction, supercritical fluid extraction, and pressurized liquid fluid extraction. For HPLC chromatographic peak can be improved by using the suitable type of column packing factors, mobile phase, for example pH, buffers, organics, modifiers, and samples.